Hi everyone, my name is Eran Kinsbrunner and I welcome you to this short session, but hopefully very insightful around keeping your regression suite relevant with production metrics and continuous feedback loops. And the reason behind this session is as we all evolve into more advanced software development practices like DevOps, Agile, platform engineering, shifting left a lot of the coding and testing to the developers, there is, in my mind, a growing pattern or a concern that feedback loops are not as efficient as they should be. And hopefully by the end of this session, you would understand where I'm coming from, but most importantly, how to avoid this risk and complication and how to really feedback loops coming from production, from customer incidents back to your engineering group. And what about myself? I am the global head of product marketing and a best-selling author as well. Now working at Lightrun, which is a developer observability platform, allowing developers to troubleshoot incidents in production, in remote clusters, Kubernetes clusters, and other complex environments directly from their IDE at runtime. If you want to hear more about Lightrun, that's not obviously the session. Feel free to reach out to me and I can provide more insights. These are just a few of the books that I've published over the past 5-6 years. Most of them are around DevOps, software development, and continuous testing. As I mentioned, I will start my session today touching the key root cause of production incidents. I'm mostly going to touch the right side of the software development, where it comes as a feedback from production, unfortunately coming as an incident. I will start by explaining what are the core or the most common root causes of these incidents. I'm going to then dive into key developer productivity metrics because they are definitely connected to these kind of things. And I'm going to touch, most important, that's the root cause of why we are here, in how to keep your regression suites valid continuously. Last but not least, everyone is talking about AI, so why shouldn't I? So I'm going to touch also about how can AI help in all of these cycle and how they can actually, how AI can accelerate this feedback loop and maybe save you some business reputation concerns, money, as well as engineering time. So let's dive into some of the root cause analysis of issues, and I'm not going to shame anyone. These are all public news. I'm definitely taking some of the things which are a bit late, not just the recent ones. So as you can see here, this is Sainsbury's, a large retail in the UK. He had suffered a system issue, which was very, very painful to their users. As we all know, many of our activities today are done in a digital manner, mobile, web, especially from our home, and we expect, I would say, 24/7 availability of websites and services. In this case, last March, this retail, had a huge glitch, and some of the things that BBC stated back then is that rigorous testing protocols in place and rigorous release planning might have been prevent this kind of outage. And you can understand the damage to the brand, but this is just one example. Another example, retail food, doesn't matter. I hope I'm not making anyone hungry here. This is about McDonald's, same month, by the way, not a coincidence, I don't know. And they also had a glitch, and the issue took them almost 12 hours, to resolve this issue. Think about the business implications of such thing, and think about war rooms and hectic days and hours before and after this incident within the engineering group. I can go on and on, but I think you are getting the picture here that even though our continuous testing development practices have evolved over the past few years, we still see day in and day out critical outages in airline websites and applications, retail, banking, and anything that serves customers in a digital way. And this can be a cybersecurity, it can be a regression bug, can be a configuration issue, can be a network issue. The bottom line is that testing needs to be done, obviously, as much as possible before production. This is not new. I've written books about it, but you need to also be smart about what's your playbook when things are happening, because as you can see, things happen in production. What's your playbook to restore services as fast as possible? And I'm not just talking here about, the DORA metrics of productivity and MTTR. I'm talking about business reputation here. And as an engineering group, what's your practice? What's your playbook when such an outage happens? How do you restore it? What are your lessons learned, practices, especially from development and testing perspective? What do you do? When I searched online, and I do a lot of searches online, I've actually landed on this very good research coming from Microsoft. So Microsoft is a well-known organization that we can trust, and they did a huge analysis and research of many production incidents, and they came up with these statistics, which in my mind and their mind are very insightful. As you can see from an RCA category, the common root causes and mitigation behind incidents, especially in production, are code-related bugs, not infrastructure, not networking, code-related bugs that are slipping into production. And that's the majority of the bugs. Second in line, which is in my mind was a surprise, but still a very significant percentage of the root cause of issues are related to dependency failures. Can be outdated libraries, third-party issues, network or infrastructure dependencies, etc. But dependency failures are taking the second line, in RCA categories. And third is infrastructure, and you can see here there are configuration bugs, databases, and authentication failures. And that's very interesting. What's also interesting, and kind of on the right side of this research, is the mitigation. Okay, what is happening as an immediate mitigation? I talked earlier about the playbook. So what organizations are doing when such thing happens is they are either doing, the majority are either looking at a rollback to a more safe, more stable version of their software. If they cannot do like a continuous integration, continuous deployment within the organization, or if it's too risky, then rollback, infrastructure changes when it applies. They're doing sometimes configuration and external fixes, etc. Bottom line, none of this is short in time. These things take a lot of time. Even a rollback can take a lot of time, because you need to understand which version fits. It might not be the previous version, because maybe you have feature flags which doesn't take place. It's a lot of things that you need to consider even when you're doing a production rollback. And obviously a code fix takes a lot of time because of the entire CI/CD cycle that you need to do. So the bottom lines from this research were showing that code-related bugs are the root cause for incidents and take the longest from a time to detect and time to mitigate and fix. And the average time to detect and mitigate a code fix are the longest. These are very important observations coming from Microsoft research, but also within Lightrun. When we discuss with our customer base, huge enterprises, they say more or less the same thing. Okay, code-related bugs are the most concerning ones. They take a lot of time to detect and mitigate unless they have a playbook in place. So I'm just putting it out there, and keep in mind the previous two slides of Microsoft and Sainsbury's, and think about how these things connect. Just connecting to the previous slide, so you see the time, the second point. So that's kind of from the same research, how much time it takes to fix a code-related bug, and the average time to detect and mitigate for different mitigation steps. So code fixes, obviously, for code-related bugs in the RCA category are the most time-consuming. So how does this scary opening of the session kind of connects or relates to metrics? So when you're looking at the most commonly adopted DORA metrics, Google DORA metrics, and I've actually done a very insightful webinar with Nathan Harvey from the DORA team and his crew. So if you want, you can check it out online and learn more about his take from the recent survey that Google DORA did. But anyone who is doing and adopting Google DORA knows that we are dealing with 4 distinct metrics. 2 of them are related to throughput within the software development, software delivery stages. And the second tier, or the 2 other metrics, are around software stability. The first ones are lead time for change from code commit to production. How much time it takes you to implement or fix a bug up until you deploy to production. A hint to my previous slides. Second is the deployment frequency. How much time it takes you to deploy from a go within your organization towards deployment into production or other remote environment. From a stability perspective and code-based stability, change failure rate. How much of your code changes results or causes a regression, a bug, a failure within your build. And lastly is the MTTR, the mean time to resolve. Once you actually messed up things, how much time it takes you to fix, to resolve the issue, and obviously restore the service. And you can understand that in many cases, these 4 are very, very much connected and aligned. And when you combine all of these 4, in many organizations, this kind of gives them a mirror of how productive they are, and that's why we call developer productivity, developer experience, and stuff like that. So these are a very, very commonly used metrics. And if you want to know your place within this benchmark, you have in these slides that I'm going to share afterwards, you have a self-check, so you can check yourself and see where you stand. From a benchmarking perspective, this is taken from the most recent Google DORA report, and you can see the benchmark table. So everything that I've shown you in the previous slide, the change lead time, the deployment frequency, the change failure rate, and obviously on the left side, you will see the top performance up until the most, I would say, it's not saying that someone is bad and someone is good, okay? You can look at it that way. I don't look at it that way because there are a lot of considerations. There are a lot of organizations which are still on a monolithic architecture. It takes them time to restore services because of the nature of their software. So it is what it is. At the end of the day, from an elite perspective, what DORA is looking at is that a change lead time should take them less than 1 day. A deployment should take them very, very small amount of time. It can be even on demand. So think about the previous incident that I gave you. It should be fixing and restoring quite fast. Sorry. So and you can see here that the low performers take them 1 week up until a month for a failed development recovery time. Okay, and that's almost a quarter of the responders in Google's survey. So a quarter within our software organization takes them a week to a month, okay, to restore service, and they have 40% change failure rates, okay? This is not good, okay? If you're talking about grades, whoever is in this segment, this is not a good sign for him. It can take him time to redeploy because it's a huge code base, it's monolithic. But if it takes them so long to fix bugs, or if they 40% of their code changes results in change failure rates, this is a very bad practice. So obviously, I encourage you to read more on the Google DORA, the DORA report, do a self-check, but these are some of their findings, and these are not the only metrics. So if you say, okay, DORA is not for me, no one mandates anything, right? So you can actually look also at standalone metrics for your development productivity and quality metrics. So you can look at the service uptime. How much of time of your service is up, okay, and operational, okay, delivery velocity, okay, the rate at which a team completes work within a specific time frame, okay, sprint, software iteration, you name it, how much time it takes you. Quality metrics, okay, there are few metrics that I see in and out. So the amount of escape defects through the pipeline, percentage of test automation scenarios versus manual, amount of open bugs in the system, which you keep piling up and not neglecting, and the overall test cycle execution time. Okay, how much time it takes you to execute, because obviously this reflects on how much time it takes you to restore service or deploy a new build which passed all of your quality gates. And there are also value stream mapping, space framework. There are a lot of methods and metrics out there that you can adopt. In my mind, you need to pick a few, okay? That you cannot not measure yourself for developer productivity and quality efficiency, especially nowadays when everything is so complicated. So pick whatever makes sense to you from your maturity perspective and measure yourself, not to compare yourself to others, but to continuously improve your own practices. Okay? With that kind of long introduction, but it's important, I want to touch the most important thing of this session, and that's closing the feedback loop, keeping your regression suites updated. Okay? So what we are seeing today, okay, what my company is seeing today, what I see talking with so many enterprise organizations, is observability today, and observability is what is on the right side of your pipeline, right? In production, in pre-production, if you like, but when it leaves your development environment towards your customers, you know, and you need to observe and monitor what's going on. These APM tools, Splunk, Datadog, which I like, Dynatrace, Elastic, and the likes, all of these tools are great, but they are not developer-focused tools. And that's a concern. I talked, as I opened this session, I mentioned my concern. So ops tools, APM tools, monitoring tools are not dev tools, okay? They don't operate within the IDEs and development environment. They produce dashboards and graphs and data which is not always actionable from a development perspective. And by nature, these tools are reactive and static. They're telling you a moment in time what's happening in production. It's not at runtime, in real time, and things like that. And I won't talk here about pricing and how much they cost. We know that they are very expensive, but I do care about one thing. Developers in this matter are disconnected from their live applications in production. Okay, they build the code, they need to monitor it, they need to resolve issues, because these are the metrics. I showed you the metrics earlier, right? The developers are measured on the metrics of their productivity, how much time it takes them to restore the service, how much time it takes them to fix the bugs, how much time it takes them to do a sprint, right? Deployment frequency, right? So logging everything just in case and analyzing later is not a good practice, because it does not contribute not just to the metrics that I talked earlier, it does not contribute to the agility of your engineering organization. And that's why, you know, if you look at observability and what it means, this is taken from Honeycomb, but it totally resonates with me. Observability is about understanding and debugging unknown unknowns. And remember this statement, because we know about testing. You test for the good and bad scenarios, but things happen, like I mentioned earlier with McDonald's and Sainsbury's and others. The ability to understand any inner system state just by asking questions from outside of the system. Okay, so you're doing it as part of the testing, but in production, in real time, with dependencies, with environmental implications, with a specific configuration that only that segment of your users, of your customer base is using, may cause a specific issue, okay? Being able to figure out and understand, and of course debug and solve these unknown unknowns within your customers in production, that's the modern observability. APM can do up until a certain level. They can flag when something goes wrong. They can give you a heads up, maybe, but for like a performance degradation. But when it comes to understanding and debugging, this is the disconnect between the ops and the devs, and that's where you need a bigger solution, a much more modern solution. And if you connect all of this, because we are in a QA summit, we are in a testing summit, this was taken from Michael Bolton. I've used it in many, many sessions in the past. It's always relevant in my case, okay? And this is what Ingo is saying, also a good friend of mine. Testing is always sampling. All the risks that are, all the tests that we could perform under the ocean, if you like. But look at the balance between what we are actually testing and what can actually go wrong, okay? There are risks that we know about, the tests that we repeat. There are risks that we can imagine, and there are things that, we're not doing anything about them. And this is where the Sainsbury's of the world and CrowdStrike of the world and other takes place. So the ocean of tests is hard, and that's why we know it. You cannot cover each and every scenario and every configuration. We are sampling, and it is what it is. We need to do the best we can. We need to automate as much as possible. This is known for many years now. But when things slips into production, when things go wrong, we need to be prepared. Don't need to immediately go and blame someone, because you need to face this nowadays reality. And with AI and AI writing code for us, things might even be worse, might get worse, because in some of the cases, most of the code that you're going to see in production is not code that you as a developer produced. Tools are actually producing some of the code for you, and you are merging it into your code base. It can cause unexpected behaviors and issues. So face the reality that things will always slip to production. Nothing you can do about it. And some of the things will be very, very bad. You need to be prepared for that. And how can you be prepared? You need to bridge between the ops and the developers. You need to employ the developers with a platform that they can immediately get this understanding. Going back to this slide, they can get the understanding and the debugging capabilities of the production issue and the root cause of the issue from their IDE, from their environment, so they can act on it as soon as possible. And once they can do what I just talked about, which is the live debugging, okay? Once a developer can really figure out at runtime against the production environment what is causing this crash, this exception, this unexpected behavior, and can fix it, that's where I'm coming from, and that's where the loop needs to be closed. And what I'm seeing today is that regression suites are not well maintained. You have a bunch of test cases, you're maybe maintaining them in a code repository in Git or others, but feeding this repository of regression test cases with war rooms regression bugs, okay? This is something that, in my case, falls in between the chairs. And let me explain. A bug was detected. Let's take McDonald's, okay? I hope, again, I'm not making anyone hungry here, but let's go with McDonald's. McDonald's has an outage. The developer is using a live debugging to troubleshoot from the IDE, is able to add logs, metrics, traces. He can figure out why the issue caused the service to go down. He's fixing the issue, okay? What's happening from that point needs to be an ongoing continuous practice. This developer needs to feed the test manager, the QA manager, the QA director with the entire incident details, the code, the classes, the code base that was impacted by the bug, and most importantly, what was done to fix the bug, because it also may have impacted other areas. For that purpose, the team, the QA team, the testing team, need to figure out which test cases across all of the layers of testing, you know, the pyramid and stuff, which test cases need to be baked, created, integrated into the pipeline for future recurring test suites. That's the regression ongoing maintenance, okay? And to be honest, when there is a war room for such an outage, like CrowdStrike and the likes, you know, everyone is so occupied, so busy in fixing the bugs, restoring the service and deploying to production. The day after, 2 days after, honestly, I haven't seen too much evidence that a refactoring or an audit of the entire regression test suite is being conducted, or even a testing window is being provided to the testing team so they can develop more regression suites, more regression test scenarios that can ensure that such regression does not happen anymore. So when you take live debugging through developer observability and putting aside the APM tools told us that McDonald's and CrowdStrike are down. Good. From that point, it's the live debugging platforms and the developers that own the entire cycle of fixing, restoring, and within the QA and engineering group, adding more test cases so this thing does not happen again. So when you're using what I've just said, this process, I'm just trying to connect everything to our metrics here. You can see here that with live debugging and observability, understanding the change, understanding and debugging the unknown unknowns, you know, it impacts all of these metrics that we talked about earlier: the lead time, the deployment frequency, the failure rates, and the time to restore service. So when you have this within your shift left tool chain, can be an IDP within platform engineering, if you like, it obviously allows you to improve on the metrics that we talked about earlier, the DORA metrics, but also it gains within the engineering team better confidence and results in lower overhead and much more. So this is kind of closing the loop, using developer observability, live debugging to gain more understanding in what's happening in production, restoring services fast, improving developer productivity and other metrics, which obviously impact the business and your bottom line. So that's how a modern software engineering with live debugging looks like, and it impacts, I can tell you firsthand, it impacts in a significant way your test regression suite quality. Okay, the quality of regression suite, once you're employing such a method, is going to be higher. That's guaranteed. Platform, like I've just talked to you, just putting it, the previous slide, which is maybe a bit complex, putting it all into one slide with a shift left, which everyone likes to talk about. You can see here that quality, which is the change failure rate, deployment frequency, lead time to change, and MTTR, they're all getting addressed. Last but not least, to close this session, is future looking. So I just talked to you about how live debugging, being able to troubleshoot things at runtime, reduces all of these metrics and maybe brings you to the elite table of engineering teams with AI. And this is something taken from my own product, what we call AI debugger or autonomous debugger. Think about these incidents that I've gave you examples earlier. Think about a world where you can actually take a Jira ticket and inquire the debugger for the issue itself. What is the root cause? Why is it happening? And hopefully give me the code related lines that I can troubleshoot with logs and metrics so I can resolve it. So with AI debugging capabilities, developers can actually generate hypotheses using GenAI to understand the root cause of the issues in a matter of seconds, few minutes tops, right? You get the suggestions, as you can see here, of why this scheme user with a role manager created without a company name, right? So the AI is telling you where to put a snapshot, where to put a breakpoint or a log, and how to fix the issues faster so you can reduce MTTR, improve developer productivity, restore service faster, and these kind of things. So autonomous debugging is a reality already today, and it ties back to everything that I've talked to you earlier. So get ready. I'm just saying, get ready to this new modern world where developers own the entire loop of debugging, restoring the service, and actually impacting the QA organizations that should take everything that they are doing, these developers, and enhance the regression suites so they're always up to date based on what's coming from production, not just what you're doing within the pipeline. Feedback from production is gold. This is exactly how your users are using the system, with everything that involves, environmental dependencies, network security, and many other things. So whatever you can get from production in matter of feedback, missing test cases, and of course fixing issues, just improves your code base and your own productivity. With that, I just want to summarize. Shifting left with live debugging is, in my mind, a game changer. It fits perfectly well in the new norm of DevOps, platform engineering, and microservices, remote and distributed workload applications that everyone is adopting. So if you haven't touched software quality with live debugging and developer observability and how they connect, I truly recommend you to either look at some of the things that I've written over the past year or so, go to or search live debugging, developer observability, go to lightrun.com if you like, and see how it can help you. And if you have any questions, reach out to me either through LinkedIn, email, or through any other, even my blog, and I'll be happy to assist and send you more information and materials. With that, I would like to thank everyone for your time, and I hope you enjoyed it, and I hope to see you in the next event. Thank you so much.